So we did our first lesson, which was the basic welcome to programming Arduino. We've learned a little bit about how we talk to Arduino. We understand the basic concept of input, elaborate, output. What we want to do with interaction design is learn how to interact better with people. This is my lesson on interaction design. We're going to make interactive prototypes. I want to talk about ethnography and empathy really quick because these are the two main themes that we use in interaction design. And then we're going to learn how to program things a little bit better. If anybody wants to sew their button on, if you haven't sewn your button on, the button is used to make things a little more interactive. So go ahead, start sewing the button. So the program really quickly here is we're going to take a look at what is interaction design and what is ethnography and empathy. How do we use these to our advantage? And how we, as designers, use ethnography. And then we're going to come into programming interaction. I'm going to teach you a few more things to make things truly interactive. And so you guys have a very good idea as to how to do a basic interactive program with Arduino. So what is interaction design and empathy? Interaction design is the creating of meaningful relationships between people and the products or services that they use. We want to get people involved with their object. It's made up of lots of different things, but the primary fields are industrial design, ergonomics, cognitive psychology, human-computer interaction, design research, architecture, user interface design, sociology, and anthropology. You can get a degree in interaction design coming out of any of these. So this is a basic diagram by Bill Verplank. It's like, what does interaction design do? We get a feeling. We come to know that feeling. We come to understand what that feeling is, and we do something with that feeling. So we take things in, we send it back out. This is the world. This is everything around us. We study the world. We find and realize new things, and we do something to change that. So a lot of what we do when we design interaction design is we talk about how do we do this. So we take things in, cool art, things we've noticed, people doing things, what's good in fashion, what's good in interaction. Right now, we draw knowledge maps. We do a bunch of fun stuff with this. I'll show you how to do a few of these things in just a minute. And then we do something with that. We make handles and buttons and interaction and programs. And that's what we're going to do with our hat next. You can read this at home as well. It's just a good definition of ethnography, because ethnography is not an easy word. It mostly deals with social welfare. But what ethnography truly believes is we want to study people in their native settings. If we're going to understand people, we don't want to try to read books about them. We want to go there and live with them and try to figure out who they are and what they're doing by watching what they do and studying them, whether they like it or not. It deals with not only material culture, but spiritual culture as well. We do very fun spiritual stuff if you're so inclined. But participant observation. You are there, you are an active participant inside of that culture. It is very, very vital to ethnography. We can't design for people unless we're around people, we know people, we probably like those people. But we don't like those people, we're going to change them to be people that we like by making and creating something to change that behavior. What's key for me is how they dress. You know, it can be a lot of other different things for you. It might be what languages they speak, how they do food, how they do housing, how they do lots of different things. I'm a fashion designer, and I concentrate on how people dress and interact. The key to ethnography as a fashion designer, at the very least, is doing rapid ethnography. And rapid ethnography can be any of a series of things. And here's my master list of rapid ethnography. How do we do rapid ethnography on people? And there's a couple of these I want to take a look at more closely, but let's go through the list. First is secondary research. Anything we can find anywhere in the world in books on the internet about those people, about the people that we're researching and studying, about our society, our culture, whatever we're doing. Number two is collaging. Collaging is great. And we use collages, pictures, words, to try to bring things together that didn't make sense before, or try to put new and interesting combinations together. And collaging is a very powerful tool for realizing things that aren't so obvious and putting new things together. Card selection, we'll do a little bit of this together. This is always a little bit fun. Cognitive task analysis. If we have to ask somebody to do something, we have to tell them to do something, we study them as they're doing that thing and try to figure out where they do it wrong. If we hand them the hat and tell them to do something with our hat, we see what they do with the hat. We try to understand, do they push the button? Do they understand what the button does? We sit there and we cognitively try to figure out what they're doing. We can draw character profiles. We can try to figure out who are the people using our product, who are the people using our service, who are the people using our hat, and try to describe that person, and try to figure out new wants, needs, and desires, and uses that are true for that person. The key to ethnography is that we get outside of ourselves, because we're so very used as designers to designing something that we would like. Because yes, there are other people that would probably like that, but as really good designers, if we study other people as well, we can make our product not only good for us, but good for lots of people. And that's what a product really becomes truly great. Rapid ethnography also refers to spending absolutely as much time as possible with your subject. So if we're gonna be making a hat, we want to spend a lot of time with people who wear hats, and just hang out with those people who wear hats and try to figure out why they wear hats. So you can just you've seen my hat. You go and find people who like hats, go to their house, see all their hats, have them talk about their hats, ask them questions about their hats, spend time with your hat. Hang out with your hat. Take your hat on a date. That's definitely rapid ethnography. Behavioral archaeology. Behavioral archaeology is when we study things after people have used them. If we're going to use the hat analogy, I love to go to secondhand stores when I'm fashion designing. Why? Because we can take that hat, or we can take that leather jacket, and we can see how that person used it. How did that garment change form? We look for traces of the person that was there before we got it. We go and see their hats. We see where the hats are stretched out. We see where the velvet hat has lost its velvet. We study when something's been used, how it was used, and how we can get to make that better or change that. 5 whys. This is a fantastic thing to do as a designer. Ask why 5 times to somebody. Perché in Italian. Ask some people, why are you wearing a scarf? And then they respond, why are you wearing a scarf? Why does it feel cold? It's wintertime. Why is it wintertime? Interesting. In asking people why 5 times, you can get down to deeper motivations. Why they're wearing a scarf might not be very good. But when we talk about aesthetic choices, it really works well with aesthetic choices. If we ask people why 5 times. I have a 4-year-old brother-in-law. He's great at this. He's the best rapid ethnographer I know. The kid can ask perché or why endlessly. He's just trying to figure it out, and I get it. We should take a good example from him. Word concept association. Write down a bunch of words that go along with your theme, and then put a series of objects out that kind of go with your theme, and have people put words or cards to the object, and try to figure out how different people associate different things with those. Still photography survey, it's just watching people and taking pictures of them. They might not like the fact that you're taking pictures of them, but you're studying them. You're trying to see how they do it differently than you expected them to do it. And you can really figure out a lot. If that works great, let's jump down to time-lapse video works even better. Because in time-lapse video, we can go back and find the anomalies. It's like Madonna said, if 99 people tell me that they like my song, I want to talk to the one person who didn't like my song. You're looking for that one person, and that's the person you want to design for. Because the other 99 people already get it. Narration. Ask somebody to do something and have them say what they're doing while they're doing it. They have to describe what they're doing. We figure out why people do things the way they do because they're telling us why they're doing it the way they're doing it. And it's really good for figuring out how people think differently than we do. And it's really important when we start to build interactive devices and when we start to do things like a hat like this. Because yeah, it makes a lot of sense to us. Or me as a designer, the hat makes perfect sense to me. But I'm telling you this because I wrote the code. And I've got an intimate relationship with it at this point. I understand that you have a different relationship with it. And you might want it to work completely differently. But as a good designer, I want to hear from you as to what you think it should do. Error analysis. Try to figure out where people are going to do it wrong. Never, as a, what is it, the guy who wrote Hitchhiker's Guide to the Galaxy, never discount the universe's ability to build a better idiot. There will always, if you make something idiot-proof, there will make a better idiot. So try to find that and try to figure out how somebody is going to screw it up. We're almost there. Scenarios, and then we're going to do a couple of these together. Scenarios. We want to write down situations where it's going to be used. We want to write down and literally draw out and just stick people, nothing complicated. Where are people going to use our hat? How could they use our hat? What could be a new use for the hat? What could be a different use for the hat? If in drawing out our scenarios, and we're going to run through one of these together, we find a new use for our hat. And very simply, because Arduino uses software, we can build in all these extra uses quickly. It's not a solid circuit. It hasn't been built to do one thing. It's software, so we can keep telling it, keep adding on these things. And all of a sudden, you have a very complex, complicated hat that does lots of different stuff. And that's when people really get to like it and know it better. And then finally, cognitive mapping. Try to draw out how different people think. Engineers do a lot of this. I'll show you about a little bit of it in a minute. Body storming. This is another one I really enjoy. If you have to do something, pretend you're doing it. If you're astronauts going to the moon, act out like you're astronauts going to the moon. Get down on the floor, pretend you're all strapped into the space shuttle, fly off together. If you're wearing the hat, oh, I've got this hat here. Boom, I'm going to put this hat on. I'm going to tie it up. Simply acting things out. Acting things out is going to help us find new uses for it. It's like when we started with the hat, we wanted to do it with pom-poms. But we quickly realized great big pom-poms. Here's a pom-pom. I had these really wonderful glowing pom-poms when I started working with the hat. And it was supposed to be all pom-pomming. But we quickly realized that there wasn't going to be time to make pom-poms. Because if you think straps are complicated, pom-poms are straps with pom-poms added to it. So we had to find a different way of doing it. But it was in that acting it out. It's literally moving our hands, trying to figure out what we can do with it. We're like, oh no, straps work fine. It eliminates the straps just as well. Narration. Narration is just explaining how you do a project. How would somebody use it? Or hand somebody a hat and ask them to tell them what they're going to do with that hat. Especially when you have something with a lot of electronics integrated into it, ask them this. This is a really great book. If you've never read it, Understanding Comics by Scott McCloud. It's a doctoral thesis on how to read comics. It's fantastic. And he literally goes through and describes these things. Very, very good book. And you really should try narration sometime. This is called The Treachery of Images. This is not a pipe, is what it says in French underneath there. Because it's not a pipe, it's a painting of a pipe. It's not actually a painting of a pipe, it's a drawing of a painting of a drawing of a pipe. So it takes you through that whole narrative level. Card sorting. Card sorting is really good. You should probably try to do this at some point. What you do is you sit down and just write 16 words on a piece of paper that have to do with your hat, or have to do with the thing you're working about. And what you want to do is take those cards and hand them to somebody and ask them to organize them. Don't tell them how to organize them. Just tell them to organize them and let them go about it in the way that they're going to do it. Some people will put them in really nice little quadrants. Other people will put them in piles. Some people will make a great big mess and put them everywhere. But you get to start to see how people think about different things and how things are related in their minds. Do we want to try this? Yeah, let's do it. Everybody, do we have a piece of paper? Do we have paper? Yeah, let's do this. Everybody.
Do we have paper here? Pardon? Qualche foglio ce l'hai?
Yes.
Può fare qualche pezzo?
Perfect.
We had the paper count. Now
No, it has to be a little bit more. One per persona? One. Alessandro per one per persona? That's what we can manage. Yeah, so here we go. So this is really, really simple to do. If somebody wants to rip a page out of their notebook, oh, here we go. We got some more. Perfect. Awesome. Everybody grab a piece of paper.
No, io non partecipo.
Oh, come on.
No, nel
It's
senso
easy.
che lo faccio fare sempre agli studenti. Va bene,
Perfect. Paper. Right over. Look for it. No, because it's not going to see how you and I do this, because we're intimately involved in the project. Okay, card sorting. Very easy. You start card sorting by folding your paper in half. Ooh, awesome. We have 2 cards. We need more. Fold it in half again. You can imagine how this is going. I don't have to run you through it. Fold it in half 2 more times. Yeah. And at this point, if we unfold our happy little origami cards at this point, we should have 16 cards. Now I want to ask each of you if you found some. Okay. You need to fold one more time. Okay. Now what I want each of you to do is write 16 words about your hat. Don't ask anybody else. Try to think about 16 words that go with the hat that we've already made. What are 16 keywords that describe our hat?
But why is it order?
How's that?
With a logical order or without?
Without order, because we're gonna cut them all up in a minute. Okay. Okay. The next one we talked about was the 5 whys. Now the 5 why one was developed and brought to us by Satoshi Toyoda. He is the chief architect of Toyota cars. And he's the one that came, that's why the Toyota cars back in the 80s had things that no other cars had. He was asking the users of the cars, what did they want to have inside their cars? So I can't tell you how important the 5 why question is. As a designer, you should have people organize your cards and then ask them 5 times, why did they organize the cards that way? And you'll get down to figuring out exactly why people do the things they do. I can't stress 5 whys enough. It's very, very good. Another one that's really handy and you should all have in your sketchbooks, draw the experience. Even in stick people, horrible little drawings. Don't draw the objects. We all draw the objects as designers. As designers, we're really good at drawing objects. What we're really bad at usually, and it takes some experience getting into, is drawing experience. What does somebody using this product look like? What does somebody do with this hat? How do they approach this hat? What do they do when they approach this hat? Why would they approach this hat? And when we draw the experience, we start to figure out, disegnare l'esperienza, non disegnare l'oggetto. We start to understand exactly what the experience is about. And we start to figure out new ways of making that experience better. And I'll show you one of these in programming. Oh, because when I do this, when I do this with people, I don't want people talking during this period. Like if we were to sit down, if we had time, we would sit down and draw the experience out right now. If we want to, we can all draw the experience. I recommend everything you design, draw the experience out with it. Draw lots of different experiences out with it. Try to find new and different ways for people to use it. So many people like Marco will use it to keep his knee warm. So how does it work different as a knee warmer instead of a head warmer? But it's great. You're constantly looking for the anomaly. Find the one person out of 100 that's going to use it differently than everybody else. The last thing is cognitive task analysis. And engineers are really great at this. And we can learn a lot from engineers when it comes to cognitive task analysis. We sit down and we write down every single decision. It's also called decision trees. You can just sit down and every time somebody has to decide to do something, you write down what decision they can make. And just if you sit down and work your way through that, this is for figuring out more things that a program can do. Just sit down and draw what your program does and start adding things to it. Don't go over the top because you'll confuse people, but get it to a good working point. I think the last one I really like to do is affinity diagrams. What we're going to do is just simply write down a keyword in the middle, write down 5 keywords that go around that keyword, write down 3 descriptions or 3 things that go along with that keyword.
It's a mental map.
It's a mental mapping as well, yeah. I like to call them affinity diagrams because it creates affinity, but it just simply gets you down into something and gets you thinking deeper as to what that part of the program or what that part of the object could do better. And then you can turn around and turn that into programming, which is what's great about software. Perfect. One of the things we really like to use as interaction designers, what we do with this is the empathy response. As designers, one of the things that works most effectively for us is the sense of guilt. When people feel guilty, they like to do things. When people see a soft little frowning puppy, they want to pick him up and make him feel better. One of the most beautiful examples of this, I'm going to reload it.
Go back.
There you go.
Anyone would feel guilty when looking at you.
And I'm going to have to do this one more time. One of the our first examples of this is the old MacBook Black. We also know how the Mac simply has this LED on the front of it that fades in and out. It looks like someone is breathing. They've added an anthropomorphic system to your computer. Your computer now looks like it's alive. It's sitting there breathing. What this does mentally to you, it says, oh, my computer's a person. If there's another person in the room, why am I ignoring him? Or why am I ignoring her? It's sitting there, it's breathing, it's patiently waiting for you to go and talk to it. It's that poor little guy sitting in the corner who's just sitting there and like, nobody wants to talk to me. And so we want to go over, we want to open our computer because then it starts talking and interacting with us. Again, it stops breathing. It's having a conversation with us at that point. And it's one of those primary ways that we can evoke a sense of empathy. We want to make people respond to our programs. We want to make people respond to our objects. And with programming, we can figure out ways, even with a blinky little light, that's one LED, they have effectively created a way for people to feel guilty about not using their computers and giving them a want or a desire to use their computers. Because it just sits there breathing until you go and give it some attention. So always think of your project like the cute little puppy that nobody wants. Because that'll give you some new and interesting way to get people to use your project more, or use your product more. And when you use your product more, you create a significant relationship with that object. And we use empathy to create that significant relationship. And anything we can do to make that better, we create a stronger relationship for that person. So, interaction design is where we do all of this. Interaction design in our programming model falls in the elaboration stage. We've already got the input and the output, and interaction design can lead to new inputs and new outputs. But we want to concentrate usually here on the elaboration, on the programming phase of things. Interaction design is IXD, just in case anybody ever sees it around. That's the abbreviation for it. Let's see. Object interactivity relies entirely on the capability of an object to be able to communicate via physical components, program opportunity. So we have to have physical stuff and programming. So we're working between the physical and the software, hardware, software. The 3 things we need to consider while we're working on programming interaction are this. What is physically possible and how do we do it? This is the mechanical physical realm. Which components realize the desired function and how are they connected? Go back quickly through your components and make sure it's possible. And then which logic describes the behavior and how do we, it's still in Italian, sorry, and how do we program it? So the last thing we always ask ourselves is, oh, we want it to breathe like a little puppy so people come and love it. How do we program that? Thus, programming interaction. going to start with two things here. We're going to do analog output. We've already done analog input, so we're going to start talking about analog output because analog output is how we fade in and out, and digital input, which is just a little bit different. So we go from ethnography to what's possible, a possibility, into software or programming to get here. So let's get a little more solid with this. If we want to do the breathing, that breath motion, the fade in and fade out, we've all already seen it because it's in the hot hat program. You saw how the LEDs fade. Instead of just turning on and off, we get that nice fade in, that nice fade out. This is done through an analog output because this isn't simply high or low. This isn't simply on or off. This is getting brighter and getting softer. And to be able to do that, we need to be able to fade things up and fade things out. So what we have is a function called analog right. We've all done digital right. We also have analog right. And what analog right does is it simply gives us a range. Remember the byte was 255? So we have 1024 for analog input. But when we're doing analog writing, we work on a scale from 0 to 255. If this is an LED, we can think of it as such. 0 is 0 volts, 255 is 5 volts. 0 is off, 255 is full brightness. Again, this is limited as to what ports we can do it on. And these are available on 3, 5, 6, 9, 10, and 11. You'll notice our LEDs are connected to 10 and 11. Because these are the ports on which we can do analog. This analog fading is accomplished using pulse width modulation, or as I like to call it, fake analog. Pulse width modulation, or fake analog, does this. Instead of sending high, this would be like 100% would be high or low. So high is 0 is low, high is 5. What it does is it sends a pulse. It sends a beep, 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 fast enough that it's simulating. So it's not getting a full signal. It's getting a really, really fast signal, faster than humans can actually see it. And so what's actually really happening is that LED is flashing so fast that we don't see that it's flashing, but it's never reaching full brightness. And in doing that, we can make that LED fade in or out. Let's see here. And here we go. The frequency of the output is around 490 hertz. So that means that it can blink up to 490 times a second. I'm right. Engineer? 490 times a second is 490 hertz? Yes. So that's faster than the human eye can see. As I said before, 255 is simulating 5 volts. 0 is simulating no volts. And we just do that by basically sending pulses for longer. So really low would be very small pulses, faster pulses, very fast pulses. All that matters to us is that it makes it fade in and fade out. So how do we write this? What we need to send here, we're going to come down in here, is analog write red strap W. What's W? W is this for loop here. Now remember the for loop that we did earlier? This is how we time things up. We're saying that W starts off as 0, so that in this case, because we're telling it that the W is the brightness of the LED, it starts off at nothing. It starts off, and then it's going to keep going up to 255. So it's going to go all the way up to full brightness, and on its way to full brightness, it's going to move at a step of 5 each time. W plus equals 5 means instead of going up by 1 each step, go up 5 each time. Because if we go up by 1, it just happens so slowly that it's not really useful. Stepping, we're doing a step, it's like a guy who can go up 5 steps at a time. So that the brightness actually fades in and fades out just a little bit faster. I'm doing a little trick here, and I'm going to show it all to you right now. In the straight, there's a program called Strap Fader. If you want to load the Strap Fader program, you're going to see that the green fades up and the red fades out. Then the red fades up and the green fades out. But I'm having to do that with the same number W, because we only have this counter here that's counting from 0 to 255. So what am I doing? I'm saying, well, the red strap simply does this. It goes from 0 to 255, and it counts up, and it counts up, and it counts up. Up, 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 up. But if I want to fade the green strap out at the same time, how am I going to do that? Because I can't, I've only got one variable that's getting higher and higher and higher and higher. I'm going to use math. We love math, no? No, we don't love math. Math is going to get us through this. What am I doing here? I'm saying that the green strap is 255 minus W. So it's the opposite of this. This one is building up. This one is 255 minus the W value. So one fades up, the other fades down. The only thing that's really key to notice here is that when we wanted to make it do a mathematical function, just like algebra, and believe me, we all loved algebra, we have to put that in parentheses. So just remember that when you do a mathematical function, quando fai qualcosa matematica, devi mettere parentheses. You have to put the parentheses in to do the mathematical functions. Okay? So I know it's kind of hard to go from interaction design to this really quickly, but this is how we simulate breathing. We're fading up and we're fading down. Bennett? Awesome. Okay, just remember that the difference between an analog signal and a digital signal is that when we work with an analog signal to read in, we go from 0 to 124. When we do a digital read in, the digital read can only be high or low. Ricardo explained this a lot yesterday, so I won't go into it too deep. But just remember, analog is the staircase where we can have lots of different values. Digital, on or off, high or low, 1, 0, nothing else. So, this is the interactive hot hat program. And what I want to just simply do here is start thinking about how can the hat be more interactive? What else can we do to the hat? Right now, what does the hat do? The hat blinks red, fades in and out red until it gets to a certain temperature and it turns green. Well, what else could it do? We do have a thermistor here. We can measure lots of temperatures. Anybody want to have a brainstorming? What else could we do with the hat?
Measure our temperature.
Measure our temperature, definitely. What other temperatures could we reflect? Che cosa altro possiamo fare con il capello?
Water sensor.
What's that?
Water
But
sensor.
we can add more sensors, but if we only have the temperature sensor, what else could we do? Using what we only have now, what else could we do? Well, we could say if somebody's really hot or really cold.
Yeah.
So let's put what I've added here, but we could add another one here. So if it's under, and let's change this around. Let's put this, if it's under 12 degrees, so if it's really cold outside, to blink red really quickly. Your hat is saying, oh my God, there's something the matter. It's really cold. Why aren't you wearing me? It's so cold outside. You're going to freeze. You've got to put the hat on. You're creating that sense of emergency. It's another empathy. It's not an empathy response, it's an emergency response. But you know, for an empathy, we could have it sitting there just slowly pulsing red like it's dying really slowly. So something to get people to know, oh my God, it's really cold. What are we going to do about this?
You have a sound or vibration, or you're talking about implementing without adding.
Without adding. I'm just talking about interaction design. We already have our inputs and outputs defined. We can certainly add more input and output. But given what we've got right now, and this is where interaction design really works well, given what we got, what else can we do? Anybody? How about this? If the hat, if the hat gets over 30 degrees, so if it gets really hot, the hat blinks green. Green fast. So it's going to blink, 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 blink. It's saying, oh my God, you're overheating, you're going to start sweating soon, you've got to take me off. So now the hat is starting to interact with the person. It's saying, oh, it's really cold, you have to put me on. Oh, you're cold. Oh, now look, you're hot. It goes from red, it turns on the green. And then it says, oh my God, you're too hot, you need to put me down now. Until it gets cold again and it starts yelling at them again. But we've created a relationship with the hat. The person, especially computer geeks who don't really monitor their own internal temperature very well because they're people that are kind of outside of their bodies. We all work on our computers a lot. We aren't thinking about our body, we're in our mental space. We have a hat there that's thinking about the temperature for us. It's telling us when it's hot, it's telling us when we're cold. It's telling us when we should put the hat on so we don't get sick. It's telling us when we should take the hat off so we don't get sweaty and get sick just the same way. So how do we do this in code? That's the question I'm asking you. Okay, here, I'm gonna help you do it for you. We need to learn one thing really quick, and I forgot the slide for this. I am so sorry. We've done an if, and this isn't right anymore. We've done an if, we've done an else. What we need one more thing to make this happen, is we need an extra if. We need the else if. So we say first if this is true. Let's go ahead and write this out. We can just do this right here. We can say if the temperature, we'll just write 10, is less than 12, then we're going to tell it to blink really fast, red. And then we're going to say else if the temperature is, let's say this is from 12 to 21. So else if temp is greater than 12. Ooh, and I'm going to have to teach you a logical variable here. I'm so sorry. This is supposed to be part of the advanced class, but we want to make this happen, right? If we want to test if two things are true, because we need to test if two things are true here, what we have to put is 2 ampersteps. And I just do those backwards. Yes. If we want to test two different things, if we want to be like, and we need to put these in parentheses, if we want to test two different things, what we need to do is put this in if the temp is greater than 12 and it's less than 21. So what we're going to do is we're going to put 2 of these in. No, it was right the first time. 2 ampersteps. This means and. A. Se questo è vero, e questo è vero. And temp is less than 21. Then do this. So we make a little right bracket. What's that?
What's that?
That's the curly brackets. Bracket. Yeah, and this is so much better when I write it out. This is, you can load this up. This program is already there in Hot Hat Interactive. Then what am I going to say? One more time.
We're closing that.
Else if, let's see, we want to see if it's over 21 degrees, but less than 30. So if temperature is, let's see, greater than 21 and temperature is less than 30, do this.
Yeah.
Let's see, close those off. Brackets. Do this. And then we can pretty much assume that everything else is going to be over 30. So all we have to do at the very end is write else. Do this. pulling the ring very quickly. This program's already written for you. Yes. This is getting kind of advanced. I know.
Non sparate sulla croce rossa. Quanto manca il coffee break?
We can do a coffee break now, dai.
Sure, we have cappuccini, but we have another presentation too.
Yes.
Do you remember?
Yes. What time we got? 4:30. We're good. Okay, let's do one last thing really quick. We'll take the coffee break. Let's do digital input. That'll get us to our button, and then I can teach you modes, and then we take a break. 5 more minutes, then we have a break. Let's go. 5 more minutes. First we erase. Oh, it's terrible.
Yes. Guarda che tu spendi studenti, quando dopo ci sapeva le lezioni senza prima.
Okay. So please, remember, declare your pins. Pins have to be declared as input or output. And that gets really important when we start doing digital output, or digital input, excuse me. So remember, we have 2 different commands, 2 different verbs we can use, digital write and digital read. And we have analog write and analog read. Which one have we not done? Digital read. So we're going to jump into digital read really quick. Remember, very simple concept, but we have to understand this well. Analog is from 0 to 1023. Digital is high or low. So with digital input, we have to simply be able to do high or low. And Ricardo explained this really well yesterday. And the fact that if we get over 0.7 volts, when we're reading, it's high. If we're down below 0.2, it's low. What's important about this is it can't be 0. It can't have a port that has nothing on it. And that's why we put that resistor into there. We create a very, very small amount of circuit of current because it has to be able to read something. If the Arduino goes to look to the digital pin when it's doing a digital read and there's nothing there, it goes crazy and it's like...
You can fluctuate up or down.
Yeah.
So you might get wrong value.
Or it can just be like, what the hell are you talking about? I've seen Arduinos totally flip out at about this point. So we want to put that famous resistor from yesterday in there simply so that it's always getting something. But it's a really tiny little something. When we push the button or we close the circuit, it gets a really high something and it knows it. And it knows we get that really high something. So we can create, and it's just simply that. It's just like Ricardo explained yesterday. So that allows us to get to party mode with our pad. So if we talk about interaction for just a minute, it's really great. It's really functional. Our hat functions great. If we take a look at that hot hat program we just wrote, if it's really cold, it wants attention. Then it starts warming up, and then it gets hot, and then it gets really hot, and it doesn't want attention anymore. And that's great. That's fun. That's fine. It's very functional. But what happens when we want to wear our hat to a party? Well, we need to start being able to make our hat go blink, blink, blink all the time and have a lot of fun and be a little crazy. So let's create different modes for interaction. So we have the button on the hat, so all we have to do is hit ourselves on the side of the head, and all of a sudden we're dancing. So this is where the textile button comes into play. We can tell our Arduino that when that button is pressed, do something different. Now, what's really simple about this is we're just doing a simple one. This is a very simple beginning to this program. When the button is pressed, do something else. What's that something else? We're going to learn random really quick here. So first we read the button state. So we have to ask in our program, is the button turned on? Se qualcuno ha preso il pulsante. Because the button state, that's just a variable that reads the button, is equal to digital read the textile button. Così questo chiede alla pulsante se è preso or not. It just asks, hey button, are you turned on? And what are we going to get back here? High or low. And then we use our while loop, durante. And we're going to say while button state is equal to high. Because remember, button state can be high or low, and while it's equal to high. Remember our logic? So this is saying is equal to. è uguale a. Say button state è uguale a alpha. Do this. And what's it doing? It's just going crazy. We have a variable here called random d. Remember, you can't use the term random, so random d is just the term I always use for my first random number. So random d calls a function called random. And we'll look at this in just a minute. Random returns a random number. Random si ritorna un numero casuale. From the first number to the last number, so somewhere between 50 and 1,000. So if we're talking about our LEDs, it's going to blink really fast. 50 would be a tenth of a second, no, a 20th of a second, or it's going to blink for an entire second. But it's going to choose. And what happens? It turns the right strap on for that amount of time. It turns the left strap off for that amount of time, because we're saying to wait for random d. And then it just does the opposite. It asks for another random number, it turns the green one on, it turns the red one off, it waits that amount of time. Then what does it do? It goes back and it checks, is the button still pressed? So as long as we hold the button down, it's going to sit there and party. So random is really, really easy. All we have to say is random, we give it a minimum number and a maximum number, and it comes back with an integer number. There's a lot more to do with random if you go and read the code base, if you read the reference. The random numbers aren't so random in the end, so if you want to get a really random number, read how to work with random. But all we really need to know is how to be like, call a random number. We create an integer for the random number, we ask for random. Okay. Quickly, we're almost there. 2 more minutes, then we'll have a break. So this is fine if we want to be able to hold down the button and the hat does something. But when we're dancing, we don't want to have one hand on our head. That looks kind of dumb. So what we need to be able to find is some way to switch it from one thing to the next. When we push the button, it goes to the next program. It goes to the next block of the program. It does something else. And what we have is a very, very wonderful function called switch. Switch simply says, do this thing, do that thing, or do the other thing. And all we have to tell it is which case to run. So we'll need an integer. An integer is the route. Quale strada. So we're saying route, and what switch says is if it's case 1, do this. If it's case 2, do that. This one has case 3 as well. So if it's case 3, do that. We have an extra little thing here. There's also default. So if it isn't any of these things, do the last one. So it always finds a mode. So we're going to run with case 1, 2, and default, not case 3. Because if it ends up being the number 4, accidentally, it's just going to sit there and do nothing. And there's nothing worse than something doing nothing. So we're going to add one more mode to our hot hat. And that's ambient mode. We're just going to have it slowly fade green, slowly fade red. So when we're tired of dancing, we can go sit in the corner, and it just fades and fades and fades and fades, like we've already seen. So we're simply going to have to do a textile button that can switch between 3 modes. Case 1 is party mode, case 2 is ambient mode, and case 3 is default mode. And our default mode is our temperature mode. There's a program that I passed around on the key. Please, if you have not got the version here, the one on the CD, remember if and else if, it has an else if problem. So it never, ever, ever finds ambient mode. So please take a look at that. Go ahead, open this up, take a look at it. If you haven't sewn your textile button yet, get your textile button sewn on so you can load up the Hot Hat Interactive Modes program. And basically all this says is it's got 3 different sections of all the other stuff we've done today. And it says when, all it says is it reads the button, and if the button's turned on, switch to the next mode, go to the next mode. So take a look at this program, because it'll show you how you switch modes. And that's simply this button state, digital read textile button. it changes route to the next route number. Okay? Awesome. And then I just wanted to have a brainstorming session, but we can do this while we have some Ken teach you. What else could you do with a textile button and just a temperature sensor and a couple of LEDs? Think about it. You know, this is where you start to be like, I've got this. What else can I do with the software? If I'm wearing it in party mode, maybe the hotter I get, the more it starts dancing. Yes.
Uploaded it. This is it in the
Let's we can ask them too. Okay. So it's in temperature mode right now. With the press button? Oh, this is Hot Hat Interactive. There's a different program called Hot Hat Interactive Modes. Yeah, you want the modes program. Remember, you want Hot Hat Interactive Modes. There's a program with modes on it. Hot Hat Interactive is just the one that does all the different temperatures. Hot Hat Interactive Modes is when we can start hitting ourselves in the head. Hot Hat Interactive Party is the one we just saw. Hot Hat Interactive Party is when you press the button, it goes into party mode. When it's not pressed, it does something else. That actually might work really well the other way around, come to think of it. It's always in party mode, except when we touch it and it tells us how hot we are. Sorry.
Is there a demo?
Yes.
No, demo. If you are dancing and your friends go to try it, demo function. It's not random. It's not when you push. I don't know.
Demo's a great idea.
Because if you go in a party with this hat, I suppose they all want to try it.
Yeah, well, that's what's cool about it. Goes to fading, it goes to party, or it tells you how hot you are.
Yeah. So you have to put a target inside, and then with the right demo, push.
Believe me, if you have a big orange thing on the side of your hat, somebody will.
Something about. But when you want to take it with light, push.
Great. Go deeper. There are lots and lots and lots of projects, even in Italian, already done here. I contribute even to the Italian code database with my students at the Sapienza, so please get here. There is an Italian community. If you're not in the forums yet, log on to the forums. The forums for Arduino are great. There are lots of people all around the world that are there to help. There are people that already write Arduino, that if you have a problem, write your problem. It's not just English. Remember, Arduino is an Italian project and an Italian product. There's Spanish, there's lots of Portuguese guys. There's tons of people from Portugal. I don't know why that happened. Very popular in Portugal.
Yeah.
It's cool. Get onto the forums. We're here to help. That's it. So just remember, think about when you've got something. Don't leave it simple. Make it fun. And remember, like Paula said, you have to have something for when you demo. That's why I like party mode. I give everything a party mode. Why? Because people always want to see what it does. And after I explain the functional thing, they're like, yeah, but does it blink? So you just push the button, it goes into party mode, they're like, ooh, ah, wow.
Oh, can you tell me what time?
You can tell